So good morning. On behalf of Motorola, thank you for the opportunity to spend time with this group. We very sincerely appreciate the opportunity to speak with this tremendous group of folks that are established and gathered here today. So what I thought I'd take you through very quickly is a little bit of context around the cyber world. I'd like to start there with the big world, and then we'll work our way into a few of the key tenets for building secure solutions and a little bit about what we're doing at Motorola Solutions. So first, I like to start here to give you an idea of think about what the world around us looks like. Have you seen this slide before, anybody? So this is the Vatican in 2005 at the time of Pope Benedict's papal inauguration. Now, if you roll forward to 2013, this is the same setting at the time of Pope Francis's papal inauguration. So what happened there? I mean, a lot of things, obviously. So the mobile broadband internet came into being, the smartphone came into being, social networking happened and became mobile, YouTube. The way the world communicated changed in a fundamental way, and that obviously has tremendous cyber implications. For what it's worth, there is a smartphone or a phone in that diagram, and we're pretty sure that's a Motorola Razr. And then, more current events such as last night. This was, the bottom was Jukebox in Gabby's performance last night. That's what the world looked like when we were there. So it finds its way in all different facets of life. If you think about cyber, though, I mean, the main point of this slide, if you notice, 25% of cyber breaches, network cyber breaches or system cyber breaches are caused by insiders. 73% are caused by basically human mistakes. So that speaks, I think, a great deal to the complexity of cyber and what is happening in the world today. Saw a couple of interesting statistics from CTIA in the U.S. About 2% of smartphones or devices are infected with malware in the U.S. And more emerged countries such as Japan and Israel. 40% or more are infected in countries such as Russia and China. And if you look at third-party malware, third-party applications not coming through app stores, over 90% of those are themselves infected. So it says a lot for policy and procedure. They attribute the app store's rigor in terms of screening and vetting applications and also the practices of the network operators for why some countries actually have a better record on this than others. If you think about, the world in terms of mega shifts is the way we kind of step back and look at some of the bigger things that are happening, and we see this repeatedly. And Avi actually kind of referenced this as well about collaboration. We used to think about the network. We all would affiliate with a network, and that became sort of our service provider. Now it's clearly the world of networks. Our devices will connect to the network or the networks that actually provide the capability that we need based upon QoS, based upon cost, based upon whatever requirements are there. The world of human augmentation, technology has become much cheaper now. So it used to be all about the human being performing the actions. Increasingly, technology has made it such that automation can replace the human being, especially in places where cost is effective. The upper right, if you think about the world becoming a platform, the smartphone is a very powerful enabling platform for innovation and development. It's fundamentally, think of it as the mobile computer of today's world. Future platforms are buildings, infrastructure, vehicles. Those become platforms around which innovation occurs. And then finally, the world shifts from what I would call contextual computing that is helpful in context, to anticipatory computing. The technology makes decisions and makes recommendations in a complex world on behalf of us before we even necessarily know to ask the question. So if you look at all these things together, it has tremendous implications for cyber and our dependence upon technology. So rolling forward into the context of building secure solutions, the one Motorola slide around how we deal with technology in Motorola, we invest annually about $1 billion in R&D on a $9 billion revenue stream. I run the Chief Technology Office, which is a very small, ideally larger, but small portion of that budget. And one of what you see on the left are the key technologies, or some of the key technologies we look at. At the top is security. I think it's fair to say that in times gone past, except for in very special places such as military, most companies viewed security as a necessary evil, something they had to invest in to sell their products, but they really couldn't get a return on investment. It in and of itself was not saleable. It was a necessary precursor to sale of something else. That has flipped, I think, consistently now across the world, where security is no longer a means to an end, it is the end. It is a distinct competitive advantage and competency that we at Motorola recognize, and we're cultivating that. Back to the point that Avi mentioned a second ago around incubators, we have an incubator within Motorola as well, and that's what you see on the right. It's basically fed by customer research, the people that have the right-brained way of looking at things, the ethnographers of the world, living a day in the life, and then they feed into our incubator, which is effectively like a little startup within Motorola, a lean culture within Motorola, so that we can increment, iterate very quickly, fail fast, and get onto the right solution. So that's, I think, a very important component of innovation, and I think it's applicable even in something as rigorous and disciplined as cybersecurity. It starts with a policy and having a mindset around how to approach this sort of thing, and Motorola many years ago started down the path of proactively defining an information assurance framework inside of the company. It obviously starts with policy. You have to apply governance around policy. We influenced a program roadmap, and then finally that drives our architectural decisions for products going forward. But it really comes down to people, process, policy, and technology. Those are the key components that one has to manage and continue to increment on. I thought it was interesting that recently the National CERT from the Office of the PM recently issued an RFI basically pulling for information around these topics about how to actually influence and be smart around people, process, policy, and technology to try to guide the company or the country. Motorola will certainly contribute what we can to that RFI in response. Back to the point about how technology is infused. I think the world, when we used to think about cyber, it was people communicating with people, securing the communications for command and control and those sorts of things. Now what's happening with the Internet of Things and increased ability to put intelligence at the edge, we see the cycle of what we call capture, analyze, decide, and immobilize. So capture is bringing all of that intelligence from what we're calling the ever-advancing intelligent edge. Sensors, let's face it, vehicles, smartphones, everything, pieces of technology we carry are all very evolved sensors that provide feedback and input. Bringing that in a secure way to an analysis engine so that decisions can be made that are then ultimately mobilized to take action upon it. And increasingly that loop becomes real time. The analytics of old was day or days of turnaround. Now we see that cycle in a real time kind of closed loop. So the structure that brings that all about has to start with the user experience. What are you trying to accomplish, and how do you get that to the human beings that are involved, delivered by an architecture that, of course, is then built around the intelligent edge and differentiating technologies. Starting with the user experience, I think security, that's one of the big impediments to security, is it becomes a barrier or becomes a detractor from the UX. The more layers of security traditionally one puts in place, the more difficult the technology is to use, because yes, you have to wade through authentication procedures and sorts of things like that. Or you have to change the architecture of the technology. So for example, if you went to a zero footprint device, obviously there's no content in the device, so that's a good story from a security point of view, but it seriously detracts from the user experience that one can deliver with the device. So it's a constant battle of working through those trade-offs and finding ways so that the users can actually be secure but not be impeded from doing what they need to do in their day-to-day work. A few things going on. I guess this is the ugly American slide. I apologize for that. A few things here. There's FirstNet in the United States, which is basically a nationwide entity to create a broadband public safety first responder network. The legislation requires that it's based upon long-term evolution or LTE standards. Motorola, obviously being long-standing supplier in the public safety arenas, will be a contributor to that, and clearly a key component of that, leveraging commercial technologies, is how to secure it, how to make it resilient in times of disaster and times of need. So we're applying our expertise to that about how does one wrap around those capabilities. We spent quite a bit of time with other three-letter acronym government agencies, the NSA is referenced here, around how does one bring commercial technology into a world where it can be applied for what's traditionally a very purpose-built, rigorously secured environment. And we'll come back to this notion, we call it our Assured Mobile Environment Platform, we'll come back to that, but it's basically how do you take what amounts to a smartphone or a consumer phone and derive off of that a secure platform that is suitable for use in large entities such as the NSA. A couple of other things that are worthy of note. In the United Kingdom, the Home Office there is in the process of working through a tender to replace their nationwide Tetra network, which is run by Airwave, with what is fundamentally an entire communications facility derived from commercial technology. So the idea is take mission-critical communication and move it to an LTE network that is actually provided by the indigenous carriers such as a Vodafone or an O2 in the country. So it's a big shift. In this case, there is no private network technology at all. It's basically a service, an MVNO type service wrapped around an existing carrier network. So challenges in that, obviously security, quality of service and how that's derived from a technology like that. And then, of course, what's happening here in Israel, the military cellular program itself is a similar kind of bent on that, which is a mixture of public and private technologies to derive what amounts to highly secured, highly resilient command and control and critical infrastructure services. So we'll talk more about that, and Avi alluded to it, but this notion now of blending consumer, commercial world, and purpose-built worlds together brings significant challenges from a cyber point of view. So very simple, I'm probably preaching to the choir, and most of you could probably tell me about how this works. But if you think about the good old days we had credentials of users. We had basically a security perimeter around the information that was being managed. The users had their credentials to access that. The rest of the world was firewalled from that. So it was a pretty straightforward environment. But now, obviously, the users have gone mobile. The access technologies that they use to get at the network are different. The actual compute resources are disaggregated and virtualized and pulled out of the security perimeter. Resource sharing, increasingly this notion of sharing data across different facets has become important. And the net is the perimeter is dissolved. So now people have to be able to live in this world where the resources are configured from a variety of sources and with a variety of disciplines. A complex slide, but fundamentally what this is basically saying is we have to leverage standards in a world. The standards themselves, they are a means to an end, they are not the end. So obviously working through this notion of identity federation in a world where we have so many different credentials, so many different endpoints, and so many different service providers, one has to work through where do the credentials come from? How does one get authorized to access the data, access the transport and the services that are there? Strong authentication has to be there, and we'll come back to this, but passwords are not obviously sufficient. Passwords, especially if I have passwords for each different service I access, we're back to that user impediment in terms of usability. And one organization, the FIDO Alliance, is an interesting one. It's Fast Identity Online is the name of the intent there, and their whole point is to supplant passwords with other forms of authentication on a device, so biometrics, for example, and those sorts of things. But to make that interoperable and extend that, trying to improve user usability. And then finally, attribute-based access control. This notion, and Avi definitely mentioned this on his last slide, about people have to collaborate, and metadata is key for how security credentials can actually move around across disparate services. We think about, obviously, now a complete solution. So we talked a little bit about the devices on the right, the network in the middle, which may or may not be, but increasingly is not dedicated to the purpose. And then finally, the enterprise at the left, or in what may be the enterprise, may be government or specific services within the government. Weaving all that together so that you get an end-to-end secure solution when pieces of it may themselves not be trusted. So one key component of that is some work we've done, and I alluded to this earlier. This was what we had done with the three-letter acronym agencies in the U.S. government. This is what we call our AME 2000 architecture, and this is the basically taking a commercial phone or a commercial technology and making it secure so that it's FIPS 140-2 suite compliant. So it has hardware root of trust in it, an encryption engine, as you see there, which is an SD card-sized device, manages and protects data at rest, as well as provides the ability to encrypt data in motion. So this has been certified by three-letter acronym government agency in the United States, actively being deployed. It's being looked at among other parts of the world as well. So the reason for telling you this piece of the story is this is a platform and a capability that we leverage forward. It still requires this notion of a hardware root of trust. You have to start with what did the device actually boot? And if you can't know that, then everything from that point on is kind of difficult to tell. But the notion of minimizing the implications on the consumer device or on the base device platform such that the security is enabled increasingly easily across different technologies is helpful. A little bit about Motorola and Israel and how we think about working together here. So Motorola has been in Israel will be 50 years this year. I think we were the first country to actually set up shop, if you will, indigenously inside of Israel a long, long time ago. And it's been a tremendous, tremendous relationship and run. Still over 1,000 active employees here, so we have a major presence here. You can see some of the projects that we've worked on in the lower left. And this is the plateau and the foundation upon which we have collaborated over many years. And the reason we did that, back to Avi's point about innovation, in the end, innovation is the only sustainable advantage. And there's no question that this is a tremendously innovative culture. And this conference is a great example of how different facets of industry, government come together to solve problems. And so that's a culture and a capability that is unique in Israel that we highly value. A couple of things that we worked on a few years back, and you see the kind of the timeline here on the chart. We worked on the ACE 3600 system, which was basically a SCADA-based implementation to secure critical infrastructure. This was done with a utility company here. Motorola basically provided everything that you see in the bottom of the architecture diagram, and then the key components that are actually managing the RTUs and working with the RTUs in the core infrastructure. So we learned a lot together. Now, the reason this is important to Motorola, and this is a pattern that we have repeated back to why in Israel and why we invest so heavily here, this technology and solutions now being evaluated by the Department of Energy in the United States for deployment in critical infrastructure there. So what we learn, what we do here, obviously has applicability in other places. The latest thing that's kind of the new news, if you will, in Israel that we're working on is the military cellular system. So this is similar to what I've talked about earlier. The idea is public systems, private systems based upon commercial broadband technologies, long-term evolution, or 4G as it's known, a private core network such that the services that are derived for the military on this are really hosted in a core network that they own, but they leverage the footprint of coverage of the indigenous commercial carriers, augment that where they need to, and then of course run secure mission-critical services across that in a very private and protected way. This is just a drill down on the architecture a little bit further. I think if you understand how these systems work, then I don't need to go through this slide. If you don't understand how these systems work, I don't have time to go through this slide. So we'll just move on here. And then the last phase, I think, is if you take what we just talked about there, military cellular, the first phase is deriving services such as, we'll start with the basics of voice, push-to-talk, telephony, email, short message service, and then increasingly the data services get more complicated. And of course, real-time video and the holy grails of the kinds of communication that can be brought over a broadband network start to come into fray. Next step is how does one deploy such a network, or how does one erect such a service and capability as agencies become very dependent upon it, if they need to project force or if they have a national disaster and the indigenous networks are actually either overloaded or inoperable. So this notion of a deployable, or what we call an incident area network, how does one deploy and push a broadband network in the coverage that it is needed? Tremendous cybersecurity implications for this, because LTE technology is not designed to actually have credentials brought with it and turned on and off at convenient points in time. So how does one then take a network, turn it on, make it be interoperable so the people that need to use it can use it, but at the same time keep it secure? So that's some work that we're doing now, and obviously that will have a big play, we think, in military cellular, but it has huge play for public safety first responder networks across the world as well. So in closing, just again like to thank you for the opportunity to be here today. It's a tremendous gathering of folks. Cybersecurity, it used to be information assurance, now it's cybersecurity. The stakes are very high. I have the privilege of working with a lot of very senior people in the U.S. government, and they all pretty much consistently predict that there will be a geopolitical cyber event, not a target breach. I'm talking about a geopolitical cyber event within 2 years. So the stakes are very high, the complexity is very high, and we're making it more complex as we start to wind private and public networks together. So this is not only a necessary technology from our point of view, it needs to be a core competence, and that's why we're investing so heavily. Thank you very much.